Today we are going to discuss about the color space and typography for multimedia. Right, this is the third topic of this lecture series. Right. Okay. Then see what is color. Color is a sensation registered when light of different wavelength is perceived by the brain. Simply, we can say color, or let's say you are looking on an object, right? We can see, let's say it is blue color. How can you see this one in blue color? How can you see see an object, for an example, in blue color? Let's say this is your object, right? How can you see this one? Uh, to see an object, we have to have a power source or a little light source, right? Simply we can say it is the sun, right? Some electromagnetic waves are yeah, some electromagnetic waves are coming from sun and interact with our object, right? Uh, in the electromagnetic spectrum, we have a specific electromagnetic wavelength we called visible wavelength, right? Visible wavelength. We can say the visible wavelength has 7 colors, I think, rainbow colors, right? Then by this object, it will absorb some kind of wavelength and reflect the rest. If you can see an object in blue color, what it means, it absorbs all other wavelengths and reflect blue color wavelength. The wavelength related to the blue color will be reflected by the object. Other wavelengths are absorbed by the object. When if you can see an object in red color, what it means? That specific object is absorbed all other wavelengths and reflect the wavelength related to the red color. That is the way you can see an object, right? It is the physical way. Then when we see a color on your window on the laptop screen, how you can see it? Let's say it is a LED display. LED display. Then how you can see a specific color? I wrote this letter in red color. Then you can see these letters in red color. How you can see this one? In this specific area, the LEDs covering from this specific area will be light up in red color. This is the way you can see this area in red color, right? Right? Two different scenarios. First one, we call these objects as passive objects and active objects. Active objects are, we can say these objects are generating some light waves by itself, right? For an example, LED bulb. When we supply a voltage to a LED, it will generate the relevant color by itself. We called those types of objects as active objects, right? Then we are looking at a chair, in blue color chair. We can't see it without a light source. We need a third party light source. A light bulb, it could be a light bulb, sunlight, or any other way. We call those types of objects as passive objects, right? Passive objects. We are mainly talking about active objects because we are dealing with computer system or displays. right? We are talking about the active objects, right? We are not mainly consider passive objects in this, like under this topic, right? Then uh, primary, all the colors are generated by using three primary colors: red, green, and blue, RGB colors. Using these RGB colors, we can create any different types of colors by adding different portion of these three main colors, right? By adding different amount of red, different amount of green, different amount of blue, we can generate various or range of colors by based on these primary colors. Right. When we talk about the color, it has four main properties. Actually, three. Lightness and brightness are very similar thing, right? Overall, properties of a color we can consider under three main topics: hue, saturation, and lightness or brightness. Let's take one by one and discuss furthermore. Hue means, uh, let's say, we can say primary color of the object that you have. Hue is the primary color of the object, right? It is a combination of red, green, and blue, right? Red, green, and blue. Red, green, and blue. I had a mistake here, right? It's a combination of red, green, and blue. When we change the hue, the color, primary colors of your image, let's say image, is going to be changed. Saturation means how the primary color is far from gray, right? When we decrease the saturation, your image, the color of your image will be very close to the gray color, right? When we increase the saturation, you can see a high intensity, a colorful image, right? Very colorful, very bright color image you can see when we are increasing the saturation. Then we can say saturation means it is how far of your image color from the gray, right? Gray intensity, gray equal intensity. I will show an example, then you can understand about this one much better. That lightness and brightness, those are very similar thing. Lightness is the amount of light that are coming from the image. How the amount of light that are reflecting or emitted from your image to a user or the eye, right? Uh, it is mean by lightness or brightness. When we increase the lightness, you can see a very let's say very light image. When we decrease the lightness, we can see a darkish image. Let's get an example by using Photoshop. Photoshop. Let me open the Photoshop and import an image to this one. Let's see. Okay, I will import an image. Okay, this is a mango, right? Image of a mango. You can see the right side of the image is bit dark, in bit darker than the left side, right? Then the lightness of this left side is high with compared to the lightness of right side, right? Then let's see. I will select a specific area from this object. And go to image and adjustment. Then you can see there are some adjustments. I will select hue and saturation. Then a window will be opened, something like this. Then using this window, you can adjust the hue, saturation, and lightness of this area. Let's see when I change the hue of this image. Uh, just see what are the differences that are happening on this image. If I increase this one, you can see the primary colors are changed. See, primary colors will be changed. Other intensity, saturation, all are keeping steady, right? Without any changes. If I change the hue, the colors will be changed. Primary colors will be changed. When I decrease the saturation, you can see the color of our image is very close to the grayscale. See, then I increase the saturation, you can see it will give us a bright, full, colorful image, right? When we decrease the saturation, it is getting closer to the grayscale image, to a grayscale image, right? When we increase the saturation, you can see this is a very colorful image, right? Then we can say the saturation is the how far your primary colors is from gray, right? How far your primary colors is from grayscale image, right? Then if I change the lightness, see, it is getting darker. When I change the light of this image, lightness of this image, it will getting darker. When I increase the lightness of this image, see, it is getting bright. It's not changing the saturation, it's not changing the primary color or the hue, but it will control the amount of light that are coming from this image to our eye, right? When I increase this one, you can see the image will getting lighter, right? More light are coming from this image to our eye. If I decrease this one, see, it's getting darker, right? Those are the main properties of an image when we consider about the colors, right? Right, then what else? Okay, again, the three main properties: hue, saturation, and luminance, or the brightness or lightness. Hue means the basic primary colors. When we change the hue, it will change the primary color of your image. Then saturation, it is control the primary colors from grayscale image to a light or colorful image. Then lightness or brightness will be control the luminance. That is the word luminance of the light, luminance, right? Luminance of your image. Right. Then color models. This is very important topic, right? When we're dealing with digital devices, we have to think about the color models. These color models actually what does is combining primary colors, red, green, and blue. It is given a way to combine those primary colors to generate different colors, right? Different models are given different algorithms to combine those primary colors, right? RGB is the very basic color model that we are using in digital devices. All right. In CRE monitors, we are using RGB color model, and the intensity will be vary from 0 to 255 range, right? By adding value in between 0 to 255 for each color, we can generate a specific color, right? Let's see an example. As you can see, let's say I will change this one to blue color. Then you can see this is the given RGB values for this color, right? 16 red, 19 G green, and 222 blue, right? It is pure blue. This pure blue, you can see uh, R and G will be getting very closer to 0, and B value will be getting very closer to blue, right? For the maximum for the blue color. If I change this one to greenish color, you can see the value for the G is getting closer to the maximum value for the green. Then I select a reddish color, you can see red. Amount for the red will be getting very closer to the maximum for red color, right? Right. Then this is the RGB color model. We can this is a Cartesian coordinate system, 3D Cartesian coordinate system, right? This y-axis is allocated for blue color, green axis is allocated for green, and this one z-axis, x-axis allocated for green, and z-axis allocated for red. Then blue, completely blue means or completely one for this blue value is blue, pure blue. Then this is pure red, and this is pure green, right? We can give this coordinates in 0 to 255 range as well, right? We can say this one as 0 0 255, this one as 255 0 0, this one has 255, sorry, yeah, 0 255 and 0 for green. The combination of blue and green, we have a color called cyan. 0 255, maximum of blue and maximum of green. The combination of red and green, we have this color yellow. 255 maximum of red, 255 maximum of green, and 0 the minimum of blue, right? In the origin is represented the black, all are zeros, right? All colors are maximum, we can come up with the white color, 255, 255, and 255, right? This is the 3D axis for RGB color model. Right, this is another example for RGB color model, right? You can see these axes are allocated for three main colors, R, G, and blue. Then purely blue means blue color, right? Purely red is red color. You can see this edge is in red color, this one. Then purely green is this one, right? Purely green is this one. Then we can come up with the large number of colors by combining these three different main or basic colors, and we can come up with the huge number of colors. When I slice this one, let's say I'll slice this one in this point, you can see we have a different types of images, different colors, color combinations, right? If I slice this one furthermore through the r-axis, see these colors are much closer to green and blue because very less amount is added to these colors in red, right? Very less amount is red added to this color. Uh, high amount is added in blue and green, right? 53 for red and 400, 143 for green and 111 for blue. Very closer to blue and green color. If I slice this one in red axis, you can see these colors are very closer to blue and red, right? Very little amount of green is added to these color combinations. We can create millions of colors by combining different amounts of these basic colors, right? Okay, okay. Let's see this one. See in this slide shows when we divide an image into three different color channels, red channel, green channel, and blue channel, you can see we can divide the content, red content of this image into red channel, green content of this image to green channel, and blue content of this image to blue color. By combining these three different channels, we can come up with this image, right? All the images are created by using these three different color channels, right? I mentioned in the very first lecture, we are called image in as a 2D grid, right? 2D grid. I draw this grid in the very first lecture as well, right? We have a 2D matrix or a grid. For RGB image, we have three uh, grid for three different channels. Red grid for red channel, green grid for green channel, and blue grid for blue channel. When we overlap or we combine those different channels as a single image, we can come up with this type of RGB image. We called these slots as pixels. We can put a number in range of 0 to 255 for each of these slot or a pixel, right? For RGB image, we have three these types of grids for 2D matrices. For grayscale image, we have just only one 2D grid. We have only black and white and the variations of black and white. Grayscale, for a grayscale image, there's only one 2D grid. For RGB image, we have three 2D grids for three different color channels. Right. Then YIQ color model. This color model is mainly used in NTSC colors TV, right? Y stands for luminance. Luminance. Luminance means uh, how amount of light that are coming from from the image to our eye, right? This is very important because eyes are very tricked with luminance, not the color. The eyes are mainly focusing on, mainly attacked on luminance, not the color, right? I will show an example. This one. What is the most attractive image? Left side one or right side one? Left side or right side?
Right side.
Right side, right? Because it has high luminance with compared to low one, right? That is the reason why we called eyes are very trigger with high luminance. Therefore, Y part is very important. It is calculated by adding this amount of red, green, and blue. 0.3 of red, 0.59 of green, 0.11 of blue. By adding this amount, R, G, and blue, we can come up with the value for luminance, right? Chrominance means, okay, we'll discuss about the chrominance later on, right? Uh, then this is a very another color model, YIQ. Then we have a method to convert RGB values into this model. Then we have a conversion matrix for convert YIQ model to a RGB model, or a RGB from RGB to YIQ. I'll write the relevant matrix for converting RGB to YIQ. Just note down this one. I forgot to include this one in the slide, right? Now we are going to calculate the relevant values for YIQ from RGB, right? First, we have 0.299, then 0.587, then 0.114. For I value, 0.596, minus 0.275, then minus 0.321. This one 0.212, this minus 0.523, this one 0.311, right? This is the conversion matrix for RGB to YIQ. We can replace RGB values here, and we can complete or simplify this one. Then we can come up with these equations. This one is generated or created by using this matrix, right? I hope you have an idea about the matrix multiplication, right? For this Y value, we can multiply this value with R and add this value with, multiply this value with G and add into that. Then this value will multiply with B. See, to 0.299 we round up this one to 0.3 and multiply with R. You can come up with this value. 0.587, it is 0.59 and multiply with G value, which is this one. Then 0.11, round up this one to the second decimal place, it is 0.11. It's multiplied with blue, then we can come up with this value. Then if I add all these values, we can calculate the value for Y, luminance, right? Then chrominance is the colors is respect to the luminance. Colors is respect to the luminance, right? I and Q channels are bringing the data related to information related to the color of their image. Y is bringing the information related to the luminance of your image. Luminance is the most important thing for a human eye, right? Then again, we can calculate the I by using this matrix. For the I, 0.59 multiplied with R, 0.6 times R. Then minus 0.275 multiplied with G. Then minus 0.28 times G. Then 0.321 times B. Then we can come up with the value for I. As similar to the previous two, we can calculate the equation for Q as well, right? Then I mentioned earlier, human eyes are more sensitivity to luminance of the image than I and Q. Okay, let's calculate an example. Let's do an example. Say, just try to calculate the relevant YIQ values for a specific RGB color. Let's say, right, let's say for this color, this one. What are the RGB values for this one? This bluish color. 61 for red, green for 156, and B for 138. 138 for B, right? Let's write down these values here. RGB values are 61, 156, 138. This is the relevant coordinates for this color, right? For this displayed color. Then your task is to calculate the relevant Y, I, Q values for this given color. Let's try to calculate the Y, I, Q values. It's better to use a calculator because we are dealing with some decimal point numbers. It is very easy to calculate using a calculator, right? Otherwise, it will get longer time to calculate these values. Right, what is the equation for Y? Y is given by 0.6R. Sorry, Y is given by 0.3R plus 0.59 green plus 0.11 blue. We can substitute these values into these relevant places, right? R 61, 0.3 times 61 plus 0.59 times 156 plus 0.11 times 138. Okay, then let's try to calculate this amount, these values. 0.3 times 61, 18.3. Then 0.59 times 156, 92.04. Then 0.11 times 138, 15.18. Then we can add these numbers. 1.3 plus 92.04 plus 15.18. We can come up with the number for y value is 125.52, right? And similar to this one, we can calculate I value and Q value. Using the equation for I is 0.6 times R plus, minus 0.28, I guess, green, minus 0.32 times blue. Then for the Q value, 0.21 R minus 0.52 times G plus 0.31 B, right? You can come up with the values for Y, I, and Q by using these types of equations, right? Hope you shall get an idea about the conversion in between these different color models, right? This equations are used only for YIQ model. Other color models are using different types of formulas, right? As you can see before, this image is including, if it is a YIQ model image, it will include again three channels. Y is for luminance, I is for the color in between cyan and orange, right? You can see cyan and orange. Then for the third one, Q channel is for purple and green, in between purple and green. Color informations are carried with I channel and Q channel. The luminance of your image, the information about the luminance of your image is carried by using the Y channel, right? That is the difference in between RGB model and YIQ model. In RGB model, it's completely three channels are allocated for the colors, right? Red, green, and blue. But YIQ model, the Y channel is responsible with the luminance of the image. I is responsible the colors in range of orange and blue, or cyan and orange, right? Then Q is responsible for the colors in between green and purple, right? Okay, then another model, YUV color model. This model is widely used in PAL standard TV. Sometimes you have seen this one in your television, right? If it is a LCD or LED TV, when you are turning on your TV, it will show some televisions, some brands, they will show the screen size and the standard, color standard, right? Or else you can see these all the color standards in your menu of your TV as well, right? Go to menu and just navigate about the display settings, then you can see the color models that are available in your TV, right? YUV color model is used in PAL TV standards, right? What are other standards in televisions? CCAM, CCAM. standard and NTSC standards. Those are some other examples for other TV standards, color standards, right? PAL, CCAM, and NTSC. These are some examples for TV standards, right? In PAL standard, it is used YUV color model, right? Y is very similar to the previous one. Y is carried the information about the luminance, and I and Q again the chrominance, but the difference is the formula, right? U, we called U as the blue projection because it is reducing the luminance from B. In previous case, we are calculating the I and Q by adding the different portion of R, G, and blue, right? But in this model, it is using directly the blue color and reduce the luminance from the blue and getting the value for U. Therefore, this one is called as blue projection. Another name for U, right? Then we are reducing the luminance from red value. Therefore, we call this one as red projection, right? You can calculate U and V. Y is very similar to the previous one, right? Okay, this model is also has three channels. First, Y channel is responsible with the luminance of your image. Then U is responsible in the color range green and red, right? Green and red. Then we can see a pinkish color there for the U channel. Then for the V channel, it is very greenish, right? Purple and green. The range of purple and green color for V channel. Again, U and V in this model also, U and V responsible the color of your image, and Y is responsible for the luminance of your image. Then YCRCB color model. This color model is widely used in JPEG and MPEG compression. I mentioned this compression, the word mentioned in first and second lecture. We are reducing the size of the file and without changing the quality, right? We are reducing the file size without changing the quality. We call this process as compression, right? This JPEG and MPEG compression. For the JPEG and MPEG compression, we are using YCRCP color model, right? MPEG means motion picture expert groups. In video session, video lecture, I told you this word MPEG. MPEG 4 is from MP4 is coming from MPEG 4 video type, right? And JPEG stands for Joint Picture Expert Group, right? Joint Picture Expert Group. These two file types are using YCRCP color model for compression and store their colors in the image file, right? It is again Y is responsible for the luminance of the image. Then CR stands for chrominance blue. Sorry, CR is chrominance red, right? This is chrominance red. Chrominance red, and this is for chrominance blue, right? Again, we are reducing the luminance from B. and divide by 2 and add 0.5 to calculate the chrominance blue or the CB, and reducing the amount from R, or the reducing the luminance from R and divide it by 1.6 and add 0.5, we can come up with the value for CR or chrominance rate, right? I mentioned earlier this color model is used for compression, right? As you know, RGB image, we have the numbers in range from 0 to 255, right? These numbers are very harder to process or normalize, right? Let's say you are going to build or use images in a machine learning model, then you have to train your model using these images. Images are again 2D arrays. The array indexes or pixels are having numbers from 0 to 255. This is getting longer time to process these types of numbers, large numbers. Therefore, it is better to reduce or normalize this number in between small numbers as possible, right? Then this YCRCB model, it uses the number in between 0 to 1, right? That is the reason why I mentioned earlier this color model is used for compression, right? It compressed this number range in between 0 to 1, right? If you calculate these values, you will come up with the number for Y, CP, and CR in range of 0 to 1, right? The maximum value is 1, the minimum value is 0. You'll come up with a different combination of numbers or decimal numbers in between 0 and 1, right? Then these color models, YRCB, YUV, YIQ, and RGB. These models are mainly or frequently used in digital devices or the displays, digital displays. But CMYK model is used in printers, right? We are going to print something on a paper. We have to use CMYK model, or we have to convert your image to the CMYK model without printing it. Let's say, for an example, this one. As you can see, this part, you can see here, you can see this image is in RGB model, right? Then if you print this one using a printer, you cannot get the exact color available here. We cannot get the exact color, right? Therefore, we have to change or convert this color model into CMYK model without printing or before printing, right? To do that, you can go to image, then mode, then you can see the available color models in the Adobe Photoshop. Then if I click on this one, this image is changed to the color model CMYK. You cannot change any, cannot see any changes in colors in this image, but the color model is changed, right? Then if you print this one using a printer, you can get the exact same color for this image, right? Then CMYK model is the color model that used in printers, right? Then it has three main colors, basic colors: cyan, magenta, yellow, and black. Four main colors: cyan, magenta, yellow, and black. C stands for cyan, M stands for magenta, Y stands for yellow, K stands for black. Right? You can see you have experience on this one. Inkjet printers, they have four different ink bottles: cyan, blue, very closer to blue, cyan, magenta, yellow, and additionally black. By combining these 4 different colors, we can come up with the different colors, and we can get some prints, right? Then CMYK is known as subtractive color model. What does it mean? CMYK model as a subtractive color model. We called RGB color model as an additive color model. What is the difference of this one? In RGB model, we are adding colors, right? We are adding colors, right? Let's say you are going to display something. Let's say this one, this color. You are going to display this color, this one. Then you have to supply power, the relevant, the required power for RGB, or the red LED, G LED, and P LED in this amount, right? Then you can display this color on the LED panel, right? But in CMYK model, or this technology is used in printers, right? The papers are already white, therefore we are starting with white color, right? Then, as I mentioned earlier, we can see something in a real object, all right? We have to, or it should reflect something from that object to our eye, right? When you are see something on a printed paper, it should absorb some kind of wavelength from sunlight and reflect the remaining to our eye, right? We are subtracting something, right? Completely white color has, for example, white color has 7 different colors. Then if you can see something in blue color, it means that object is absorbed all other wavelengths related to other colors and reflecting or emits or reflecting the wavelength for blue color, right? We are subtracting something. That is the reason why we call CMYK model as the subtractive model, subtractive color model, right? RGB color is we are adding red, green, and blue and come up with the different color. If you add 100% red, 100% green, and 100% blue, we can come up with the white, and all are 0, we can come up with the black. We are starting with black to white. But in CMYK model, we are starting with white. The printer papers are already white. Then we are subtracting something, right? White means all the wavelengths are reflecting, not absorbed. But if you want to see cyan color, then you have to absorb magenta, yellow by the paper and reflect cyan color. Then you can see cyan color on the paper. We are subtracting something. That is the reason why we called CMYK is a subtractive color model. I hope you have get the idea. Right. These are the things that you have to know about the color space in multimedia, right? The main properties of a color: hue, saturation, and lightness or brightness. These are the properties. Then color models, RGB color model uses a 3D cube to get different types of colors. Then we can divided RGB image into 3 different channels: red channel, green channel, and blue channel. We combining these channels, we can come up with this image. Then YIQ model. Y is responsible for luminance of the color, luminance of the image. Luminance is the most important one for a good image, right? Then I and Q responsible for the color part of the image. I is the value. I is brings data or the information for the color in between cyan and orange. Q is purple and green, in between purple and green. And human eyes are most sensitive to luminance of the image. Next, I, the chrominance I, and next Q. Chrominance is mean by the color with respect to the luminance, right? Then YIQ model also have three different channels. Y channel is responsible for luminance, I and Q brings the data or the information about the color. Then YUV color model, Y is also similar to the previous one. Y is responsible for the luminance and U and V for chrominance. The calculating using the equation used for calculate the U and V is changed with YIQ model. Right, then YCRCB color model, which is very important for compression, video compression and image compression. It reduced the numbers from 0 to 255 into in between 0 to 1, right? Then CMYK model, this color model is used in printing printers, right? Cyan, magenta, yellow, and black are the basic colors of this color model. And we called CMYK model as a subtractive color model because we are subtracting colors to generate the required colors on a paper, right? In RGB, we called it as additive because we are adding more and more colors to get a specific color. The most suitable example for the RGB additive is the LCD display, sorry, LED display, right? Then CMYK, it use the subtractive method for generate colors, right? This is the colors in multimedia. Then typography, it is very important, right? Small topic, but it's very important, right? Typography is used in used for text, right? Uh, let's say you are going to create a document, official document, then you have to think about the font sizes, font styles, font colors, lines, the line spacing, spaces in between letters, what else? Spaces in between two paragraphs, then borders. All of these contents are related to the typography, right? In these slides also I'm using typography. You can see this is a topic for this slide, right? Then this is the content. How you can differentiate? This is the topic. This is the content. How you can differentiate? See, the font size is higher for the topic than the content. And I have made some space in between this topic and the content, right? Using these properties, you can see, you can identify this is the topic for this slide and this is the content, right? And it is very important in any graphic design and documentations, right? The basic elements of the typography is color and style, font style, color, font style, and uh, font sizes. These are the basic elements in typography, right? Uh, right. I will show an example using MS Word. Right. Right. Same letter in different font styles. Right. Same letter in different font styles. Let's say you are going to write a report. You are going to write a report or a thesis for a research. This font style is suitable for that purpose? No, right? This one is not suitable for the formal work, right? This one and this one is better, but out of this one and this one, the first one is the most suitable one for report writing, report or official work, right? Or this one. This one is most suitable for formal. Then let's say you are going to create a birthday card for your friend. Then this font style is better, right, than this one. The formal fonts are not suitable for that kind of situations. These let's say fancy fonts or funky type fonts are very suitable for birthday cards like products, right? Then you have to think about the font style and the font size and the uh, font color as well. We are not using very colorful colors, very luminous colors for formal work. But when we are working with designing or something, we are mainly focusing on the luminance colors, right? Very light colors, right? Then the typography is very important for the documentation like works, right? Then we call the x height of the character. It is the height of an individual character. Height of the individual character, x height. See, the same letter but different font styles, but different font styles, same font size, same letter. The height of these letters, this one is bit low height with compared to this one. See, you can see there are some difference of this height. This one also, it is very shorter with compared to this one, right? This one is in average size. This one has another size, right? The height of an individual font, individual character is called x height, right? And when we are going to add more than one font styles in a single document, we have to think about the x height as well. Usually pick a similar x height uh, font styles in the same document, right? We are not using different x height font styles in the same document. Most graphic designers are usually pick same or similar x height character styles for a specific documents. And the measuring unit of a character is in points. These are in points: 0.8, 0.9, 0.10, 0.11, and 0.72, and so on. Right? These points are calculated by using this equation. Points are equals to 1 point is equals to 1 inch divided by 72. 1 point is equals to 1 inch divided by 72. This is the way we can calculate the point, right? This is the measuring unit of a text document, right? This is in 100 points, right? This is in 100 points. If we reduce this one, this is in 26 points. The unit of these numbers are points. We can calculate point using this equation. 1 point is equals to 1 inch divided by 72, right? Then advanced element. Advanced element in typography is the spacing. The space in between lines, space in between two characters, space in between two paragraphs. Those are the advanced elements, right? The most suitable uh, line spacing is 1.25 to 1.5 times the font size, selected font size, right? I'll show an example. Let's say this is the slide content, right? You can clearly identify these points without any doubt, right? Then let's say if I change this spaces, line space in this way, it is very ugly, right? You cannot identify the complete sentence. You can't clearly identify this is the first sentence, this is the second sentence, and so on, right? It is very important to manage the font or the line spacing of your document. If I add in too much space, is not good. If I add and space in something like this, is again not good, right? Right. Then you have to think about the line spacing as well when you are going to build a document. Right. And the most suitable line spacing is 1.25 to 1.5 times the size for font size that are selected for the document. Then these are some uh, measurements in the fonts. You can see X height is the individual height of a character. Then this is the baseline. Some letters are getting beyond the baseline. Some letters are height than the mean line, right? We have to think about the line spacing. You have to think about these scenarios by selecting a line spacing as well, right? Then capital letters are much higher than the simple letters. Then we call this height as cap height, right? Then this space, the maximum space in between these characters are called point size, right? This is the spaces allocated for this line, right? Then the next line is starting from this below of this point size and the another line, right? Then these are some measurements. You have to think about the selecting the font size, font styles, then line spacing and paragraph spacing. Then right, font styles. Font styles are very important. See these examples. These are some popular brands in the world: Ford, Coca-Cola, Instagram, then Carlsberg, right? Those are some leading companies, products in the world, right? See these fonts. If you see this Coca-Cola in this font, you can identify this, right? This is unique for this product. Instagram, anywhere if you see these letters, without reading this content word, you can identify this product. Ford also, if you see this one in a vehicle, on a vehicle, you can clearly identify, quickly identify this is a Ford vehicle, right? These font styles are related to these products. Then you have to think about it as well when you are selecting a font, because uh, font is decided or font is giving a mood or a feeling before read it, right? For an example, this one, uh, See this one. These font styles are using to show some danger. Something. This one. This is very common in film industry as well, right? Then once you see this one, we feel it is very danger, right? But if you see a rounded shape letters, it is show it is okay, right? Then let's say the colors, when you are see some characters in red color, we feel it is giving some message about the danger zone. If it's green color, what it means, it is okay, it is safe area, right? Then the font style and the font color is also giving some emotion or some feeling or some message without reading the word, right? Without reading this track danger word, we feel this show this gives a danger message for us, right? Then we have to think about the selection. This one is also danger. If you see this one, we feel this shows a message about the danger, something, right? These all fonts are used in, uh, these ones are used in some giving a message, right? Then you have to think about for selecting a font style for a specific scenario. Then the paragraph spacing, as I mentioned earlier, we have to think about the paragraph spacing as well for a good document, right? The most suitable paragraph spacing is 0.75 in between 0.75 to 125 times for selected font size, right? Then again, space between lines I mentioned earlier. Some lowercase letters have some tail, right? They are go beyond the baseline. See, they are go beyond the baseline. Some letters are go height than the mean line. Then you have to think about these things when you are selecting a proper line spacing, right? Otherwise, sometimes this fonts or letters characters are overlapping. I'll show an example using Photoshop. Let's say right. See, let's say this is the text for your document. This is very readable, right? These characters are not overlapping. The line spacing are okay. Let's say I will change this text height or the line spacing in this way. If I change this one this way, you can see the letters are overlapping each other. Then this is not readable, right? We can't identify these characters one by one. This is not good line spacing, right? If I change this one to proper line spacing, you can see this is the most suitable one for this scenario. If I increase the line spacing furthermore, this is not suitable, right? There are so much spacing in between this line and this line is not readable. It's not good for a document. Then also line spacing as well, the letter spacing, spaces in between letters. It is also, we have to think about the proper spacing as well. This one is not good for a paragraph, right? If I reduce this one furthermore, again, these letters are overlapping and we cannot clearly identify these letters. Then the letter height, see, if I increase the letter height, this one is not good, right? You can say this letters are not readable, right? If I reduce this letter height in this way, it's also not good. Then you have to think about letter height, line spacing, paragraph spacing, font sizes, font colors, font styles, all of those things we have to think about when we are working with the documents. Then line length. Line length is meant by the maximum number of characters that are available in a single line, right? For an example, let's say I have text box. Then I have some text here. You can see if I reduce this length, this text are arranging accordingly, right? If I increase this length, again the text are automatically arranging. The line length is the maximum number of characters that we can include for a single line, right? In this line, this is the number of characters, maximum number of characters that we can include for this line, right? The most suitable number of characters for a mobile application is 40 characters, right? 40 to 60 characters. This is very friendly typography for line length for a mobile application. For a desktop application, 120 characters is the most suitable uh, number of characters or the line length for desktop computer application typography, right? Then space around numbers and columns. As you can see, the length for a image for different numbers are different. See this one. Clearly we can see the space required for number 1 and number 8 are different. When you build a table, something like this, you have to think about this one as well. You have to maintain the alignment of these columns, right? It is very harder to deal with numbers, right? Number 1 has different width, number 8 has another different width, number 0 has another different width. Then you have to think about this spacing. This one is not a perfect example for a proper alignment. See the first line, it has the additional character percentage mark, then it is making uh, a bit. See, the spaces are not perfectly aligned. The columns are not perfectly aligned. You see, then we have to make a space in between these two columns, right? This is also not a perfect uh, alignment for line spacing, column spacing, right? Then you have to think about it as well when we are working with a proper documentation. Then special fonts, you can see these fonts. Without reading these fonts, it will give an idea about what this word or a sentence is talking about. Faster one, if you see this one, you can see we feel this one is about talking about some moving or fast something, right? Then this one is very fancy fonts. This one can use for some cartoons, some decorations, some funny things. We can use these types of fonts, right? These are some special fonts. Then I showed you earlier this type of fonts we can use to express some danger, give a message about the danger, right? We have different types of fonts, special fonts for typography. Then fonts and sans serif fonts. See, in these characters, I will show you this one. The serif fonts. These are some example for the sans serif fonts. Serif means you can see some additional projections are available in the corner of these letters. See, some elongated parts, some additional projections that are coming from edges of these letters. We call these types of letters as serif fonts. Sans serif means, see, the corners are very flat. Not projections are available, not elongated parts are available in these letters. We call these types of fonts as sans serif fonts. See the difference? This is the sans serif, this is the serif. We have some additional parts, right? These sans serif fonts are very suitable for the documentation topic of the document, right? Sorry, serif fonts. Sans serif fonts are widely used in these types of uh, slides, right? Because sans serif fonts are not, sorry, serif fonts are not suitable for these types of documentation. See, if I change this one to Calibri, no. This the font used in this one. This is a serif font. This is not readable, right? This is very harder to identify letters when you are reading this document, right? But if I use sans serif font style here, it is good for reading, right? Right. Then we have to think about the selecting font type as well, serif font type and sans serif fonts. Then we can summarize the content for the typography. Typography is the science. Actually, science is used in for text documentation, right? We have to think about the font sizes. We have to think about the font style. We have to think about the background or the color of the fonts with respect to the background, right? We are not using dark colors in the dark background. We have to use the light font colors for the dark background, dark fonts colors for the light background. You have to think about the serif and sans serif font styles. Then you have to think about the font style as well. Then line spacing, paragraph spacing, then spaces in between two characters, right? Height of the characters, right? You have to think about all of these things when you are creating a good document, right? Then for this point, I will give you the first assignment for you. Your task is to create your CV by considering this typography, right? I will show an example for some previous students. See this one, right? This one, it is good, right? The color balancing, color selection are okay because the background, light background, dark colors. The blue color is very good for eye catching, right? Then for the experience, he used some kind of shapes. This is also very eye catching, right? Then this font colors, this spacing, and the spacing in between two paragraphs, two sections, and spacing in between two lines are very good, right? And also this one is also very good in line spacing, right? It is somewhat good CV. See this one. This is another example, good example for good typography for creating a CV, right? in this section, right section, dark letters, dark font colors for light background, and this right side, dark background, light font styles for light font color, right? It is good. Then the color selection is also good. For these types of documents, we are not using some red, green, yellow, orange, like for the hot colors. We are mainly focusing on using black, ash, blue type colors, right? Then the font size, it is very important. This is the topic of this section. Therefore, it is he's using large or bit large fonts size, which is these are the topics, the points. Then it's using some small font size for this one, right? This is also a good example, a good typography example for CV creation. So, and see this one. See, you can feel this content are not good, right? Arrangement of this content is not good, the first thing. And all the backgrounds are white color. It is very uh, not attractive actually. It is only selecting ash color and black color. It is not eye catching, right? Then the alignment is also bad. See the alignment of this one, the border, it's not good, right? The line spacing are bit better, but the paragraph spacing are not enough, right, for this section. But in this case, line spacing is not good, right? You feel if you see this one in the first time, you feel this one is not very uh, let's say this one is not very eye-catching, right? It is not good for submitting this type of CV for a company, for a job, right? And we have to think about the color, this content arrangement, background colors, font sizes, spacing, borders, right? We have to think about all of these things, right? Then your task is to create your CV